Hello and I welcome you to my video classes on hydrology and irrigation engineering. Myself Vishwanath Avti, and we'll see that today's discussion. Today's main discussion is mainly it is related to derivation of unit hydrograph. So that is derivation of unit hydrograph from simple storm hydrographs, and in that we can discuss about derivation from the isolated storm and from complex storm, and we will discuss some important questions, right? So first we'll go through how to make the derivation from isolated storm, and we have some simple steps, right? So first step is the number of isolated storm hydrograph caused by a short spell of rainfall excess, each of approximately the same duration. So we are collecting the data of isolated storm hydrographs and of different isolated hydrograph, but if you take the duration of time, it is zero point 0.9 to 1.1 duration r, right? Are selected from the study of continuously gauged runoff. So continuously monitored gauged runoff data will be collected, right? So but the flood hydrograph used in analysis should be selected so as to meet the following desirable features with respect to the storms responsible for them. So here it is what we have to consider: desirable features of hydrographs which we are using for analysis. So we have a different desirable features requirement. First one is the storm should be isolated storm occurring individually, right? It should be individually occurring. Next is the rainfall should be fairly uniform during the duration and should cover and the entire catchment, right? The rainfall should be fairly uniform during the entire duration, and it will be for entire catchment. Next is the duration of rainfall should be 1/5 to 1/3 of the base log. The rainfall excess of the selected storm should be higher in the range of 1 to 4 centimeter. Next is after getting the flood hydrograph, right? So we have to make the next step, right? When we want to make the derivation of unit hydrograph, then we have to get direct runoff hydrograph. So to get the direct runoff hydrograph, what we have to make? The base flow separation from the flood hydrograph. So then we have to go for next step is base flow separation, and we have a three method, and you can use any one method. Next is after the base flow separation, we will get direct runoff hydrograph. And from this direct runoff hydrograph, we can make the area calculation of unit hydrograph. Then after the area calculation of unit hydrograph, then we can calculate volume of direct runoff obtained. Right, we can calculate the volume of direct runoff, and that volume of direct runoff is divided by catchment area. Why it is? Because there is an assumption the area under the direct runoff hydrograph is equal to the unit depth of catchment area, the unit excess rainfall, and it is an assumption. And from that, we can make the evaluation, and we can calculate the excess rainfall, right? And we'll see this condition when we solve the problem, right? We can easily understand how we are making the excess rainfall calculation from catchment area and volume of direct runoff, right? Okay. So then the ordinates of the various direct runoff are divided by the respective excess rainfall values to obtain the ordinates of unit hydrograph. So these four steps are very important to solve the problems. So our main intention is to derive ordinates of unit hydrograph. To get ordinates of unit hydrograph, we require ordinates of direct runoff hydrograph, right? How to get the ordinates of direct runoff? By base flow separation, correct? So then how to get the ordinates of unit hydrograph? By dividing ordinates of the various direct runoff, right? Dividing excess rainfall and dividing the ordinates of direct runoff hydrograph, we'll get ordinates of unit hydrograph. And this part we'll understand when we solve the problem. Next is after getting ordinates of unit hydrograph, we can make the plot. The number of unit hydrograph of the given duration are derived as mentioned the above, then plotted. After getting the ordinates, we can make the plotting of different unit hydrographs, right? So, but the condition here it is due to the variations in terms of spatial variation and temporal variation in the rainfall, and due to the deviation of the storm from the assumption in the unit hydrograph theory. There is a deviation of assumption, and due to this, the various unit hydrograph developed will not be exactly identical. Right? When we are getting a unit hydrograph by these methods, these are not identical. Why these are not identical? Because of deviations, right? And we'll see how to make them best derivation of unit hydrograph, then deviation unit hydrograph. Next is, in general, the mean of these curve is adopted when we are not getting exactly identical, right? Because of the deviation from the assumptions of unit hydrograph theory and the variation in the spatial and temporal variation. So then the mean of these curve is adopted as a unit hydrograph of the given duration for the catchment. Then the average of peak flow and the time to peaks are computed first. So here it is, the peak flow and time to the peak flow are computed first, right? Then the mean curve of best fit, when we are not getting identical unit hydrograph, then the mean curve of the best fit by eye judgment is drawn. Then the volume of direct runoff is determined, and any departure from the unity is corrected by adjusting the peak values. Then, as I told, there is a assumptions, right? That assumptions what we discussed earlier, the same assumptions are there. Rainfall excess occurring uniformly over the catchment during the duration dr. Here it is what, rainfall excess occurring uniformly over the catchment during the duration of the unit hydrograph, right? So then the identical duration for a unit hydrograph is one in which the small fluctuations in rainfall intensity does not have any significant effect on the runoff. Then the duration of unit hydrograph should not exceed one-fifth to one-third of the base log. One-fifth to one-third of base log. In general, for the catchment larger than 250 square kilometer, 6 hour duration is satisfactory. Correct? So then we'll see the hydrographs. So here after the derivation, right, we have a main steps, right? First one, we have to get a collection of data of flood hydrograph, isolated flood hydrographs, right? Correct. We have to make the first drawing of flood hydrograph, then we have to make the base flow separation. After the base flow separation, we are getting direct runoff hydrograph. From this we can make the volume calculation of direct runoff hydrograph. Then that volume is divided by area, right? Then we'll get excess rainfall, correct? Excess rainfall, and this excess rainfall are again divided to each ordinates of direct runoff. Then we'll get the ordinates of unit hydrograph. After getting these unit hydrograph, we'll get number of unit hydrographs, and these unit hydrographs are not identical. You can see here it is, we have a second, here it is what, second 4-hour unit hydrograph, second 4-hour unit hydrograph. You can see here there is not identical, right? Because we have a 4 unit hydrograph, 4-hour unit hydrograph of different durations, a different storm. So here is a 4-hour unit hydrograph of one storm and 4-hour unit hydrograph of another storm, right? But these are not identical. Then what we have to do, we have to make the best fit of the curve, right, by eye judgment, right? After that we are getting average 4-hour unit hydrograph, average 4-hour unit hydrograph. Then peak value is calculated. Here you can see peak value is calculated, and time per peak value is calculated first. Time per peak value is calculated first. Then we'll solve the one problem and we'll understand how to make the derivation of unit hydrograph from the flood hydrograph. So here in the problem they have given some data, right? So here the following are the ordinates of storm hydrograph, right? They have given ordinates of storm hydrograph with respect to time and discharge of a river draining a storm hydrograph of a river draining catchment area. The catchment area they have given 420 kilometer square due to 6-hour isolated storm, right? The only one storm. They derive the ordinates of 6-hour unit hydrograph for the catchment. our main concern is 6R unit hydrograph. We have to make the derivation, right? So then we'll see how to solve this problem. I'll repeat. They have given ordinates of flood hydrograph and they have given a catchment area, and we have to make the 6R unit hydrograph derivation from the flood hydrograph, correct? So then first we have to make the plot of hydrograph, right? You can see here it is a plot of hydrograph, right? So how to draw this flood hydrograph? They have given discharge values and with respect to time. So then we'll get this flood hydrograph. Then next step is base flow separation, right? So we have three method in that. First one is a straight line method, right? So here you can see they have used a different method. I have taken this from textbook, and here they have a two method. One with the peak value and peak time, right? So here it is. A is the beginning point of direct run of hydrograph, and the time at the beginning is 0, and B is the end of the direct run of hydrograph and time is a 90 hours, and P time is 20 hours. So when you get a difference between beginning and end, you will get that n days in terms of 70 hours, and it's converted into day, it is 2.91. And one more method is we have one more method is it is what we studied, n equal to 0.83 into catchment area to the power 0.2. So then after this area is given 423 kilometer square, then we'll get 2.78 days, right, in terms of days. However, n is equal to 2.9 days is adopted for convenience. By the convenience, higher value is adopted. The straight line joining A and B is taken as the divide line for base flow separation. The line of AB is considered as a divider between direct runoff hydrograph and base flow. Right? The ordinates of direct runoff hydrograph are obtained by subtracting the base flow from the ordinates of the storm hydrograph. This sentence is very important. So how we are getting the ordinates of direct runoff hydrograph? By this consideration. That is what the ordinates of direct runoff hydrograph are obtained by subtracting the base flow from the ordinates of the storm hydrograph. So here we will get the base flow values, and if you draw the hydrograph and when you join this AB after the calculation of n days, right, we will get this base flow, and from this we will get the value of base flow, right? It may be constant or it may be varying with respect to time also, right? We'll see those how they are varying with respect to time of base flow, right? So then we'll go through the calculation first, then we'll go for again remaining calculation. So here we are making the calculation of ordinates of 6R unit hydrograph. Our main intention is we have to get ordinates of 6R unit hydrograph, and to get this we have to obtain ordinates of direct runoff hydrograph, and to get this we require base flow, and for this we have to make the base flow separation from the flood hydrograph, right? So here first column we have to write down time which are given in the problem. Next we have to write down ordinates which are given in the problem. Next step is after the drawing the flood hydrograph we have to make base flow separation, and after the making base flow separation you will get these values. As I told, it may be uniform based on the graph and it may be changing. So here in this textbook they have taken 10 initially, then it changed to 10.5, again it changed to 11, and again it changed to 11.5, it changed to 12, again it's changed to 12.5, right? It will get from the graph. Then we have to get ordinates of direct runoff hydrograph by subtracting base flow from the ordinates of flood hydrograph. Means we will get a column 4 by making 2 minus subtracting column 2 from, right, 3, right? So first one is 10 minus 10 0, 10 minus 10 0, 30 minus 10 20, 87.5 minus 10 77, 111.5 minus 10.5 101, 102.5 minus 10.5 92. Similarly we will get by subtracting ordinates of flood hydrograph by base flow, we will get these values, right? So then we have to divide ordinates of direct runoff hydrograph by rainfall axis, right? Divided by 3, and we'll see how we got this 3, right? It is a rainfall axis, right? As of now, we understood up to ordinates of direct runoff, right? How to get this by subtracting base flow for ordinates of flood hydrograph. So then we have to make the first calculation of volume of direct runoff hydrograph, right? How to get volume of direct runoff hydrograph? By multiplying summation of direct runoff hydrograph ordinates. So here we got ordinates of direct runoff hydrograph, and you make the summation of all this, right? Column 4, and you will get value of 587, right? So then this will be multiplied with the time. So time is in terms of hour, but it is converted into centimeter. So then we will get the value of volume of direct runoff as 12.68 million meter cube. If you make the calculation of this, you will get 12.68 million meter cube. Next is, it is a very important and main important is summation of direct runoff ordinates. Next is a drainage area. This is given in the problem. That is 423 kilometer square, and it is converted into million meter square. Why? Because it is in kilometer square, and if you make kilometer is 10 to the power 3, right? 10 to the power 3 meter, right? 10 to the power 3 meter, but we have a square, correct? So then it is what? 10 to the power 6 meter, right? That is in terms of they have taken million, right? 423 million meter cube, right? Why? Because it is in kilometer square, and 1 kilometer is equal to 1000 meters, 10 to the power 3, right? And due to the square it will come to, right, 10 to the power 6. So then to get rainfall depth, it is very important, right? To get rainfall depth, excess rainfall depth, right? To get this, we have to get volume of direct runoff, that is 12.68, and area of the catchment, area of the drainage area. Then, and we have these values. If you calculate, you will get 0.03 meters, and if you calculate in terms of centimeter, you will get 3 centimeter, right? And this 3 centimeter is rainfall axis, and this rainfall axis is divided to column 4 of direct runoff hydrograph. Then we will get ordinates of 6R unit hydrograph. So you can see here we have a ordinates of direct runoff hydrograph, and if you make dividing of column 4, you will get ordinates of 6R unit hydrograph. So this is what final calculation, right? Okay, so then we'll go for next problem. Right here, example, a peak of flood hydrograph due to 3 hour duration. So here it is what? Peak of flood hydrograph due to 3 hour duration. How much is the duration? 3 hour, right? Very important. Duration isolated storm in a catchment is the peak flow hydrograph, right? The peak flow hydrograph is 270 meter cube per second, right? Of 3 hour duration. The total depth of the rainfall, the depth of the rainfall is 5.9 centimeter. Assuming an average infiltration loss, the average infiltration loss is 0.3 centimeter per hour, and the constant base flow, here they have given constant base flow, not varying, 20 meter cube per second. Estimate peak of the 3 hour unit hydrograph. Here they have given peak flow, and we have to estimate peak of the 3 hour unit hydrograph, right, of this catchment, right? And next is question B. If the area of the catchment is 567 kilometer 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 square, determine the base width of the 3-hour unit hydrograph by assuming it is to be triangular in shape. The triangular shape, it should be assumed in a triangular shape. See, first one is we have to estimate the peak of the 3-hour unit hydrograph, right? And second one is we have to make the base flow width. second base flow width. We'll see one by one. So first one, to calculate the peak of the 3R unit hydrograph, right? Duration is 3R and total depth of the rainfall is 5.9 centimeter. It is given, correct? So then even one more data is loss 0.3 centimeter per hour, but totally how many hour it is? 3 hour, right? And 0.3 into 3 is 0.9, correct? It is in terms of loss, correct? So then the rainfall axis, right? It is what? Rainfall minus losses. Here we have a rainfall minus losses, and we got a losses as 0.9, and when you subtract 5.9 as the total rainfall depth minus 0.9, you will get rainfall excess as 5 centimeter. So next is peak flow calculation. So in that, peak of the flood hydrograph is 270 meter cube per second. This is also given in the problem. Next is base flow is 20 meter cube per second. It is also given in the problem. Then we have to calculate the peak of the direct runoff hydrograph. That is 270 minus 20, because direct runoff hydrograph will get after subtracting base flow. Right? 270 minus 20, 250 meter cube per second. Next is peak of 3R unit hydrograph. We have a simple formula. Peak of the direct runoff hydrograph, that is 250 rainfall divided by rainfall axis, that is 5 centimeter. So then 250 by 5 will get 50 meter cube per second. This 50 meter cube per second is a peak point flow. Correct? Peak flow. It is the first calculation requirement. Next we'll go for second, that is base width calculation for 3R unit hydrograph for the same catchment. Correct. So here the assumption is the volume represented by the area of unit hydrograph, correct, that is equal to volume of 1 centimeter depth over the catchment. So here it is, assumption is what? Volume represented by the area of the unit hydrograph, that is equal to volume of 1 centimeter, that is a unit depth over the catchment. So then the area under the unit hydrograph, how to solve this? By assuming it is a triangular. So here it is what? Hydrograph, right? And it is what? Triangular. It is told to be triangular, correct? It is the starting point and is the end point, and we require peak point, and we have a peak point, that is what? 50, correct? 50 meter cube, correct? Meter cube per second, correct? So then we have to calculate this base width as a p, correct? So as it is the area of triangular, then we have a simple formula, right? Why? Because it is the area of unit hydrograph, and unit hydrograph is assumed to be triangular shape, correct? And we know the simple formula, that is half base into height, correct? So it is half, base is b and height is 50, because it is a 50 meter cube per second and meter cube per second, and it is multiplied with the 60 into 60, correct? It will be converted into r, correct? So then, and it is area of the catchment into 1 centimeter. So area of the catchment is given, it is in kilometer square, but it is converted into, it is kilometer square, and it is converted into meter, correct? And here it is a 1 centimeter, this is divided by 100, and means it is converted into meter, and time is converted into hour, right? Then it is unknown is only b, right? We can calculate b, and we are getting the base flow width is 63 hours. 63 hours. So two calculations are over. So next is the derivation of unit hydrograph from complex storm, and this is also not important in the exam point of view, but we'll go through this. Here it is, when suitable simple isolated storm are not available, the data from complex storm of the long duration will have to be used to derive the unit hydrograph. So when we are not getting simple isolated storm, then it has to be derived from complex storms. unit hydrograph, but it has some problem. The problem is to decompose a measured composite flood hydrograph into its components of direct runoff, hydrograph and base flow. It has some problem with the decompose of measured composite flood hydrograph, and the common unit hydrograph of approximate duration is assumed to be exist. There is assumed to be exist of unit hydrograph. This is the inverse problem of derivation of flood hydrograph. So we made the derivation of flood hydrograph from the unit hydrograph, and we are going with the inverse of same problem, right? Okay. Consider a rainfall excess made up of three consecutive duration of dr, and excess rainfall values are r1, r2, r3. So it is what consideration of rainfall excess of three rainfall excess of duration d, and one rainfall is r1, second one is r2 and r3 of each d hour duration, means one is 1d, 2d and 3d duration. Then, after base flow separation of the resulting composite flood hydrograph, a composite direct runoff hydrograph is obtained by separation of. See, here we have a flood hydrograph, and when you make the base flow separation, you will get direct runoff hydrograph, right? So then we can get composite direct runoff hydrograph. Let the ordinates of the composite direct runoff hydrograph to be drawn at a time interval of drs, correct? The drs. So then, as I told, there is a consideration of three excess rainfall of r1, r2, r3 with respect to drs, right? Then at various time interval 1d, 2d, 3d, from the starting point of excess rainfall hydrograph, let the ordinates of unit hydrograph to be u1, u2, u3, and the ordinates of composite direct runoff hydrograph to q1, q2, q3. So here we have to understand time duration is 1d, 2d, 3d, and the ordinates of unit hydrographs are u1, u2, u3. Then ordinates of direct runoff hydrograph is q1, q2, q3. Then how to calculate, how to get relations between ordinates of direct runoff hydrograph and unit hydrograph. So here is a simple formula of inverse method of flood hydrograph derivation. That is the relation between ordinates of direct runoff hydrograph, it is q1, that is equal to r1 into u1. So it is rainfall excess 1 multiplied by it is ordinates of unit hydrograph. And if you observe, we have a formula like this: r1, 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 it will be same, but it is changing with unit hydrograph ordinates. It is u1, u2, u3, u4, u5. Again it will be taken lesser than u, which one used the first. Here it is for q1, it is equal to r1 into u1. To calculate the ordinates of second ordinates of direct runoff, it is q2, that is equal to r1 into u2, right? Next ordinates of unit hydrograph u2, then plus r2 into next, right now it is a next rainfall excess into u1. Similarly, if you follow the same method, you will get for next discharge ordinate, it is q3 r1 into, here it is a u2, but here it is u3, plus r2 into u2. So but here it is u1. Like this you will get for discharge up to n number of discharge values, correct? But if you, and after the getting ordinates of flood hydrograph, and again we can get ordinates of unit hydrograph calculation, right? Here it is what, from the equation of 6.6, the values of u1, u2, u3 are can be determined, but this method suffers from disadvantages. This method is very complex and it's not so easy, and even if you want to solve this, you will get a errors, you will get errors, right? And this method is good with respect, with help of computers. That matrix method is there, and with the help of matrix method with optimization scheme, it is available, and we can easily solve this kind of problems, right? And as an exam point of view, you will get only step by step explanation how to make the derivation, right? As I told, isolated storm hydrograph is sufficient to explain and the problem, right? And here if you see the questions, right, only one it is asked in the June and July 2017. Explain step by step derivation of unit hydrograph, right? And for this I used K. Subramanya textbook. Thank you.